Hello and welcome to lesson 4.3. We have already done example 1, so I'm just going to do examples 2 through 5. This first one is on page 288. We're going to look at function. Organize the input, rule, and output into a function table. So that's one of our vocabulary words. I'm going to show you exactly what that means. The variable for the domain is called the independent variable. So the x, domain, independent variable, all the same thing, because it can be a number. The variable for the range is called the dependent variable because it depends on the domain. So that's one way for you to remember it, kind of like input and output. Now example 2 says to choose 4 values. We're going to change this and we're going to actually put 5 because we are going to start using something called the rule of 5. Go ahead and make yourself a note here. Rule of 5, all that means is that I need 5 values. So it's going to look like this. Rule, make yourself a note wherever you have room. Rule of 5, have 5 values in the, I guess you could just say in the table. And usually those values are going to be -2, -1, 0, 1, and 2. So that gives you 2 negatives, 0, and then 2 positives. That's why we want to do the rule of 5, so that we have different representations of positives and negatives. So if you look right here, they give you the function f of x is equal to x plus 5. So that's our rule or our equation. That's what goes in the middle here. So sorry. Good morning, teacher. Sorry about that. So like I was saying, the rule or the equation, that's kind of what we know it as. Now over here, you're going to be making your own tables. Your domain, those are all your x values. And I am going to go ahead and tell you, do -2, -1, 0, 1, and 2. So this table, we need to add in a 2 down here. And so the rule is to plug it in for x. So that's what they've done here. -2 plus 5 is 3. -1 plus 5 is 4. 0 plus 5 is 5. 1 plus 5 is 6. And now I'm going to plug in this bottom one here. 2 plus 5, excuse my handwriting, is 7. So that's what a function table looks like. If I ask for a function table, I should see domain, rule, and range. All right, so go ahead and flip your page over to page 289, and we're going to do this example together. I think you're going to find that it's easier than you may think. So if we have a function table, I'm going to try and make it bigger so it's easier to write in. It says choose 4 values, but we should know this really means 5 values, and plug in for the function table. This is our function right here, so that goes in as our rule, which they already wrote over here. So for x, I'm going to start at -2, -1, 0, 1, and then I'm going to add 2 in at the bottom. So I'm going to do -2 minus 7, which I'm subtracting these, so I'm got -9. Now, the next one, -1 minus 7 is -8. And then 0 minus 7, excuse my bad handwriting, is -7. 1 minus 7 gives me -6. You might start to see a pattern here, which is really nice. And then right here I have, let's extend my line, 2 minus 7, which gives me -5. Now right here it also says state the domain and range of the function. So I'll go ahead and type that so we can read it nice and easily. So the domain, those are all the x values, and you wrote those in, so it shouldn't be too hard to remember those. Our domain, and if you go from least to greatest, it's way easier to do this. Now that means our range, if I go from least to greatest, I'm really honestly just going in order here. -9, -8, -7. And we'll go ahead and fill that in. If you have room off to the side, go ahead and write this right underneath C. So after -7, -6, and then -5. So here's your domain and here's your range. All right, at the right underneath that example is our real world example connection. It says there are approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, so PJ, is a function of the number of jars of peanut butter purchased J. So identify the independent and dependent variables. First of all, our independent, dependent, however you want to think about it, remember that independent represents our x. So that's the one inside of the equation being multiplied. dependent, this is pretty much your answer. It's your y. All right. So right here it says, since the total number of peanuts depends on the number of jars of peanut butter, the number of peanuts, P of j, is the dependent variable. So that means number of peanuts is our x value. And then the jars of peanut butter, j, is our y value. And then number 4 says, what values of the domain and range make sense for the situation explained? And it says only whole numbers make sense for the domain because you cannot buy fraction of a jar. So when you're talking about real world instances, you need to think about numbers that actually make sense. Now the range value depends on the domain value, so the range will be multiples of 770. Because you have 1 jar of peanut butter, well, that's 770 peanuts. Now if you have 2 jars, we know we could take 770 times 2 and get our answer right here. That's why it would be a multiple. It's almost like counting by 770. So number 5, all kind of the same problem. It says to write a function to represent the total number of peanuts, then determine the number of peanuts in 7 jars of peanut butter. Realize they're probably going to throw in a question at the end here that you do need to solve. So here's our words. We have number of peanuts, which we know represents our y value, or the dependent variable, is equal to 770 times the number of jars. And we know that this is our x value. So this still looks like the equation y equals mx, just different variables. Now if we want to figure out how much is in 7 jars of peanut butter, all I'm going to do is take that 7 and plug it in for j here. Excuse me, sorry. Sorry about that, that was an announcement. But if we take the 7 jars, we plug it in for j, you can see right here that works. 770 times 7 is 5,390. So in 7 jars of peanut butter, it's approximately 5,390 peanuts. And go ahead and flip the page to this last example we're going to do together. It says a scrapbooking store is selling rubber stamps. Sorry, this is on page, let's make sure you guys are all on the right page. This is on page 290. So a scrapbooking store is selling rubber stamps for $4.95 each. The total sales, F of n, is a function of the number of rubber stamps n sold. Identify the independent and dependent variable. And I'm just going to kind of write it off to the side here so we can fit it. So I'm going to say my independent variable is this, and my dependent variable is that. Now, I like to start with naming my dependent variables because I just think that it's easier. So if we read through this, we know that the total sales, F of n, is a function of the number of rubber stamps n sold. So anywhere you see like this F of n, that means it's a function. The thing before or after whatever they're talking about, that's going to be your dependent variable. So in this case, our dependent variable is total sales. And that means that the independent variable is going to be n, which stands for number of stamps. Make sure you fill that in right underneath D, or on the line for D. Now for E, what values of the domain and range make sense for this situation? So think about a scrapbooking store selling rubber stamps. Now for the domain, which is our independent variable, it's the number we're going to be multiplying. It really only makes sense to have, I'm going to start typing it, it makes sense to only have whole, I can type it correctly, whole numbers, because you cannot buy part of a stamp. You're going to end up having to buy like the whole stamp. You can't buy half of it and only spend half the money. They don't sell things like that at this particular store. Now right here it says to write a function to represent the total sales, then determine the total sales for $5. And I think most of you would be able to say, okay, if each stamp is $4.95 and I get 5 of them, boom, I'm going to multiply. But realize you're also writing a function, right? Because we have F of n, excuse my bad handwriting, let me try again. F of n means that it is a function. This is really hard today. We have F of n is equal to, now we know that each stamp is $4.95, so it's $4.95 times the total number of stamps, which we're using in this variable. And please excuse my bad handwriting on this one. I can type it out here. F of n is equal to 4.95, which is the total for one stamp, times, or we can just put the variable in. I'm going to do lowercase n. Now, if I wanted to figure out how much for 5 stamps, I would say, okay, well, f of n is equal to 4.95 times 5. And which in this case, the total cost of those stamps is going to be $24.75. So go ahead and make sure you have that written on the section for F right here.